Hi guys, welcome to this page of the notes, and what we're going to do is we're going to take all of that income we just learned about the in-center, a point of concurrency known as the in-center of a triangle, and how we can use it to help us solve some problems. So here we go. I have given you, let's see, what have I given you? JV and KV are angle bisectors. Let me put those in red. So JV, right there, and KV, right there. Those are going to be angle bisectors. What does that tell you? Well, that tells you that point V is an in-center, right? Angle bisectors will meet or intersect at an in-center. So V is the in-center. Great. Angle bisectors of the triangle. I want you to find the distance from point V to KL. I want you to find that distance. Sorry, KL. That is going to be, oh, this line over here, KL. So let me put that guy right there in green. That guy right there. Find that distance. Okay, great. And then I want you to find the measure of an angle, VKL. VKL. Okay, awesome. So here we go. Let's just start working through this together. First, we know, thanks to the in-center theorem, we know that if you know the in-center of a triangle, it is equidistant from all of the sides. What that tells me is that the distance from V to side KJ, right, from V to side KJ is congruent to the distance from V to side JL, right? From V to side JL, right? Because the in-center is equidistant from all the sides, is congruent to V from V to KL, side KL, which turns out is what they want you to find, right? What is the distance from V to side KL? I drew it right there in green. Well, since they all have to be congruent to each other, if I know one of them, then I know all of them. And in the diagram I did, I gave you from V to KJ, it turns out to be point W right there, but whatever, it's 7.3. So that means that I know V to side KL is 7.3. That's really kind of the key idea. With in-center, it's equidistant from all of the sides. If you know the length from the in-center to one of the sides, you know the length from the in-center to all of the sides. They all have to be the same distance. Now, an angle. Well, here we go. What we've got is, remember, angle bisectors. In order to find V, I have drawn three, or I would have drawn three angle bisectors. These are lines that will split an angle in half. So this is really interesting. In my diagram, I have given you that this little chunk right here, that little chunk right there, VJL, angle VJL is 19 degrees. So what do you know about angle VJK? What do you know about that little angle above it? Well, it's an angle bisector. They have to be congruent, which means that that guy right there is also 19 degrees. So I have 19 degrees here, 19 degrees there. I tell you that angle L is 106 degrees. And guys, just like that, we have the triangle sum theorem. We know that all the internal angles of a triangle must sum to 180 degrees. That's going back to, again, a previous chapter, but all of that information we've already learned, it'll just keep coming back. So here we go. I know the internal angles must sum to 180 degrees. Well, I'm going to have 19 degrees, that's that little chunk, plus 19 degrees, which is that little chunk, plus 106 degrees, that's angle L, right? Plus this angle right up here, JKL, angle JKL. All of those angles must sum to 180 degrees, right? So here we go. Actually, if you wanted to, you certainly could, right? 19 and 19, just add those together, make this one whole angle, so then you'd have angle J, angle L, angle K. In fact, actually, I like that better. Let's do that. I know that 180 degrees is equal to angle J plus angle L plus angle K. In order to find angle J, it's just going to be 19 plus 19. Okay, so let's see here. I have 180 degrees is equal to, since angle J is 19 plus 19, that's 38. Angle L was 106. Angle K, I don't know. Let's figure that one out. We'll subtract both of these to the other side. Again, I know that you guys can do that on a calculator, not too terribly difficult. 180 minus 38 minus 106, what's left over? You're left with 36 degrees, right? So I know that angle K has to be 36 degrees. Now, here's where sort of the little, you got to be really careful about what I asked you. I didn't ask you for angle K. I asked you for angle VKL. So right here in blue, hopefully you can see this, I want VKL. I want just that little sliver right there. But I know, right, I know that VK is an angle bisector. It splits K into two equal angles. So how do I find that little sliver? Well, if the entire angle is 36, divide it by 2. Angle VKL is equal to 36 degrees divided by 2. And of course, 36 degrees divided by 2 is going to be 18 degrees. Right? Each of these little slivers, 18 degrees, that gets me the 36 degrees that angle K has to be equal to. All right, so please be very, very careful here. Again, really important idea. The incenter is equidistant from all the sides, and you find the incenter by using angle bisectors. So you can bet I'm going to ask you questions where you've got to be able to use that idea of it being angle bisectors in order to solve for an unknown. Let's try one more together. Of course, if you're feeling comfortable with this, please go ahead and try this one on your own and then just come on back and see if you got what we get or what I get here. Once again, let's see what we've got here. I tell you that QX and RX are angle bisectors, so let's go ahead and do that. QX, RX, those are my angle bisectors. Awesome, great, no problem. I want you to find the distance from X to PQ. So, I want you to find this distance right here in green. What is that distance right there? I know that it is equidistant, right? This is my incenter, so it's equidistant from all the sides. This is the easy one. If that guy is 19.2, then mine has to be 19.2 as well. So X to PQ is equal to 19.2. That just comes straight from the diagram, right? The incenter is equidistant from all the sides. So if you know the distance from the incenter to one of the sides, you know the distance from the incenter to all of the sides. But I also ask you about another angle, right? A little sliver. I want PQX. PQX. Okay, so this is going to go just like in the last one. Let's see if we can keep this straight. Here's what I tell you. Let's see what I tell you. Oh, okay, well, first let's write it out. I know that all of the interior angles of a triangle must sum to 180. So angle P plus angle Q plus angle R. Now, what angles do I know? Well, from the diagram, I know that angle P is 52 degrees. So let's go ahead and put that in there. 180 is equal to 52. Angle Q, I definitely don't know angle Q. They don't give me anything there for angle Q. What about angle R? Well, in angle R, they don't actually give me angle R. They just tell me that little sliver right there is 12. But I know XR is an angle bisector, so the little sliver above it must also be 12. Add the two together, 24. So I know angle R is 24 degrees. I'll subtract both of these to the other side, and I know that angle Q has to be what, 52 degrees? Wait, does that make sense? Real quick, I got a calculator right here. You're going to do 180, you're going to subtract 24, you're going to subtract 52. 104 has to be 104 degrees, so 104 degrees. So angle Q has to be 104 degrees. Okay, now I didn't ask you for angle Q. I asked you for angle PQX, right? So I asked you for just this little sliver right there. Well, you know that QX is an angle bisector, right? So it splits angle Q in half. So how do you find angle PQX? Well, take angle Q and divide it in half. Angle PQX is equal to 104 divided by 2 is equal to 52 degrees. All right. So once again, what we're doing is this idea of incenter. And a couple important things about incenter is that you find the incenter by drawing the angle bisectors. And we've seen how we can use that information about angle bisectors to find unknown angles. But the incenter is then also equidistant from all of the sides of a triangle. And again, in these problems, we've seen how that information can then be used to find unknown links. Thank you so much for joining me for this set of videos. I had a great time talking to you about incenters and can't wait to see you next time. Bye.